Welcome to the video on how to calculate the normal force, and let's get down to it. Alright, so the first thing that we need to know is that the sum of all the forces, alright, the sum of all the forces that are perpendicular, alright, to the surface, alright, so these forces all add up to 0, right, when the object is sitting on a stable surface, because there is no movement of the object either up or down. All right, so there's no perpendicular movement of the object, and if there's no perpendicular movement of the object, that means F net perpendicular, if we equate it, for example, to, we make a general formula of Newton's second law equals to ma. Right, if there's no movement, it means acceleration is 0, therefore this is just equals to m times 0, which is equals to 0. All right, so that's one thing we need to make sure we do understand, okay, before we can learn to find the normal force. Now the second thing that we need to understand here is that the normal force, right, if there's no any other force applied, there's no other force applied at an angle, the normal force will equal the perpendicular component of gravity. All right, so but we'll draw diagrams to show when that happens and when that doesn't happen. Right, let's start with A. Okay, so if we draw first of a free body diagram, so this is the diagram that's going to help us do a calculation. So obviously we will have your normal force, okay, upwards, and it's perpendicular to the surface, and downwards you will have your, okay, perpendicular to the surface downwards is FG perpendicular. Okay, and so if I draw this here nicely, okay, I've got FG perpendicular, which of course on a horizontal surface is just FG. Okay, and then that's normal force. Right, now I need to have a notion that fact that F net perpendicular when an object is sitting on a stable surface is equal to 0. Now the next thing is I'm going to choose direction, so I choose up as positive. When I choose up as positive, I can then write that, okay, this means that my normal force is positive, and this also means that my gravitational force is negative. So now F net, or the sum of the forces that are perpendicular to the surface, right, is going to be therefore positive normal force added with negative perpendicular component of gravity, and that equals to 0. This means that in this case the normal force, okay, we take that to the other side, so is equals to the perpendicular component of gravity in this case. And since this is a horizontal surface, we all know that this is just going to give us mg. All right, okay, it's just going to give us mg, so normal force equals to the gravitational force. Right, you can go ahead and do the calculations. Obviously, if we do our calculation, Okay, if I move it all the way here, right, this will mean that the normal force equals to your 5 times 9.8. Okay, so if you want to include, you can include it there that this is also cos of angle theta, but on a horizontal surface theta is 0, so this will be cos of 0 degrees, and you should get 49 newtons. And obviously because it's the normal force, that's up perpendicular to the surface. All right, so that's great, we've done that. Okay, so I want to just move this a little bit so that I can have space on the other side to do the other work. Okay, let me just move that. Okay, so there we go. Okay, now let's move down. Okay, so the same thing here, since we now know how to deal with it. So first thing, forces that are in the vertical, that's what we look at. We only look at forces acting in the vertical direction for us to calculate the normal force, right? Because the normal force is perpendicular to the surface, so we only look at forces that are perpendicular to the surface. So forces that are perpendicular to the surface, Fg perpendicular, and then the normal force. So in this case, if we choose our direction up to be positive, so this will mean that obviously, since we know already that F net perpendicular is equals to 0. All right, so we check all the forces involved that are perpendicular. If we chose up as positive, it means we have a positive normal force and a negative gravitational force component, right, perpendicular component, and this will result in Fn minus Fg perpendicular equals to 0, and obviously it's going to go to the other side. Normal force equals to Fg perpendicular, right, which is basically, this is just mg cos of the angle, and in this case you are going to have 10 times 9.8 cos of the angle on a horizontal surface. We all know that your angle is 0 degrees, so that would be cos of 0 degrees. Okay, so which will end up just giving you 98 newtons down perpendicular to the surface. Sorry, that will be up, so down for the gravity, but for the normal force it will be up. All right, so now let's look at when there is actually an incline, a force acting on an incline, or a force acting at an angle rather, not say acting on an incline. So how will that happen? Okay, so that force acting at an angle, it will have a component, right, a perpendicular component. Okay, so let's say this is force applied, so we'll call it force applied, right? So there is a perpendicular force, okay, of that applied force, or you can say Fay. So now that is going to be equal obviously to the applied force itself, and since that force, that vertical component is opposite to the angle, so we'll use the sine function, right? So sine of the angle. Okay, so in this case we can say that, okay, let's draw a free body diagram just only representing the vertical forces. So you're gonna have your, obviously, your normal force, and then you are going to have your you're also gonna have your perpendicular component, perpendicular component of the applied force. Okay, then you're gonna have a downward, which is the force of gravity, or rather the perpendicular component of gravity. So we have all these forces. So now, then, one thing that we should know is that F net for all the perpendicular forces equal to 0. Then we put our forces, if we choose up as positive, it means that the normal force is positive. It means that the y component of the force applied is also positive, but the gravitational force component is negative. So how do we represent that? Then we will just say F net, replace it with all of that, a sum of all those forces. So it will be normal force plus perpendicular component of the force applied minus the perpendicular component of gravity, and all of them equal to 0. So when we take these other forces to the other side, we're just going to have the normal force equals to the force of gravity will become positive on the other side, and component of the y, of the applied force, right, is going to become negative. Okay, so this will now give us, okay, perpendicular component of gravity, right, is going to give us mg. We're going to say mg cos of the angle minus, obviously that's going to be just the applied force, okay, and that will be sine of the angle. So this will be, mass is 9.84 g, and then cos of, so it's a horizontal surface, so the angle is still 0 degrees, minus 50 newtons, because that is the value of the force applied, and then sine of the angle in which that force was applied, which is 20 degrees, right? So this should give you, in this case, okay, so it should give you somewhere about 80.90 newtons, and that's obviously up, perpendicular to the surface. Okay, So let's look at when so basically you can see that when a force has a vertical component pointing up, you will end up with the perpendicular component of gravity subtracting the perpendicular component of that force. Okay, then let's look at when that force is actually applied downwards, so which means we are going to have a vertical component of that force applied, right? So that's your force applied. Okay, so we're going to have a perpendicular component of that force applied, and it's downward. So if we choose direction and we say okay, up is positive, which means we are saying okay, normal force, we know that there will be normal force there. Downward, obviously there will be perpendicular component of gravity. All right, so then you can pause the video and see if you end up being able to calculate all of that. So just so that you don't get confused, let me just draw this so that you can see that this is where what we are working with. Okay, so free body diagram only including forces in the vertical or forces perpendicular to the surface. We've got normal force upward, and then in this case then we have downward is the perpendicular component of the force applied, and we also have downward perpendicular component of the gravitational force. So we can easily just say okay, we know already F net of all perpendicular forces is equal to 0. Therefore, you are going to have, if we choose up as positive, like we said, this means that my normal force is positive. My perpendicular component of the force applied, that is negative. Perpendicular force of the gravitational force is also negative. Right, then I put it in the formula. So then instead of F net, I sum all the forces together. That means it's going to be normal force minus applied force perpendicular component, also minus gravitational force perpendicular component, and all of them are equal to 0 because there is no movement perpendicular to the surface. So in this case, then it's a matter of just working down your maths, and obviously all this go to the other side. So you've got FA perpendicular plus FG perpendicular, and this FA perpendicular is basically FA sine of the angle, which in that case is 30 degrees, plus FG perpendicular, which is basically mg cos of the angle, and the angle is obviously in that case there is the horizontal surface, so theta for g is 0 degrees, so this will be 0 degrees, and this is basically going to be force of 300 newtons. Okay, if we saw it there, so the force is 300 newtons. Okay, and then sine of 30 plus then mass is 10 G is 9.8, cos of 0 degrees. Alright, so if you put that in your calculator, right, you can pause the video and do all the work and then find out if you got it right. Right, which of course you should get something about 52 newtons, and since this is the normal force that is up perpendicular to the surface. Okay, so if we are on an incline, I think you should be used by now. How will we find the normal force? You already know how to find the perpendicular component of the gravitational force. If you don't know how to do that, then please make sure that you watch the video on calculating the y component of Fg. Okay, so make sure you watch that video. Okay, so let's look at this. Obviously there is no any force applied. Okay, so since there's no any other force applied at an angle, this is the place where we can say that the normal force is equals to the y component, right, perpendicular component. Right, so how do we get that? Because to draw a diagram, okay, we will say, okay, let's draw something nicely there. So the object will be sitting there. Forces perpendicular to the surface will have one. The first one, upward, will be the normal force, and then downward from there, right, still perpendicular to the surface, 90 degrees, right, will therefore be the perpendicular component of gravity. All right, so this will not be a problem. All right, if we choose that side as positive, the side of the perpendicular forces perpendicular to the surface as positive, that will mean that our normal force is positive, our gravitational force is negative. After you have known your direction, then you know that F net of all the forces that are perpendicular to the surface is equal to 0. So you start summing up all the forces. So you've got a positive normal force, negative y component of the gravitational force, and all of them are equal to 0 since these are the only forces acting perpendicular to the surface. Therefore, you are going to have normal force is equal to, or component or perpendicular component of gravity will go to the other side to be positive, and we know that that is basically just mg cos and not sine cos. All right, do watch a video where we were calculating the y component of gravity, cos of the angle theta, to see why is it cos. Right, in this case, so basically it's just 10, which is the mass, 9.8, which is the gravitational acceleration, cos of the angle theta, is 30 degrees. That's the angle of the incline. Okay, there we go, and that should give you about 84.87 newtons. And since it's the normal force that is upward perpendicular to the surface, so I think you can definitely tell how you should calculate F. Okay, pause the video, calculate F, and see if you got it right. All right, so for F is basically, I think by now you know, right, that there is no other force applied at an angle, therefore the normal force is equal to the perpendicular component of gravity. Right, once you have done these calculations many times, you don't longer struggle because you know where it will end up. Okay, you will end up with Fg perpendicular equals to normal force. So this is mg cos of the angle theta, and this is mass 100, 9.8 for gravity, and cos of the angle in this case 40 degrees. Right, then you put it in your calculator, and then that should give you somewhere about 750.72 newtons. And that's how we calculate the normal force. Right, if you like the video, give it a like and also subscribe so that you can see the videos that we make every time are uploaded.